right, this is unit 1.2. So in yesterday's lesson, we talked about what matter is and what matter isn't energy. And now we're going to talk a little bit more about matter. So when you're talking about matter, matter can be combined in lots of different ways. One of the ways that matter can be combined is it can be combined to form what's called a pure substance. And another way that matter can combine is it can combine to form what's called a mixture. Okay, now a pure substance is matter that doesn't vary from sample to sample. And what that means is that's the technical way of describing it. But basically what that means, it means that when you form a pure substance, such as an element or a compound, it means that those samples don't change when you look at one sample of it versus another sample of it. For example, carbon dioxide, for example, is a compound. So CO2 is a compound. And carbon dioxide is always made up of one carbon atom and two oxygen atoms. And if that changes, then it's not carbon dioxide anymore, it's something else. Okay? So a pure substance, whether it's an element or a compound, those samples don't vary from one to the other. They stay the same no matter what. Okay, hydrogen peroxide is another pure substance in that, again, it's always H2O2 and it never ever changes. Okay, well, then you think, well, wait a minute, it really can't ever change. Well, it can if you have what's called a mixture. A mixture is when things combine, but they're not chemically bonded to each other. Okay, and so for example, when you take some like some sugar and you put it into some water and you mix it up, and the sugar is still there. It's still sugar and it's still water. But if you boil that water off, what do you have left? You have the sugar left behind, because the sugar is not chemically bonded to the water. It's just mixed with the water. Okay? And so again, a pure substance is one that doesn't vary from sample to sample. It's always one carbon, two oxygens. It's always two hydrogens, two oxygens, and hydrogen peroxide. A mixture, though, obviously, I could take some more sugar and put some more sugar in there. Or I could boil off some of the water, and now the concentration of the sugar would be higher. Okay? Or even something as simple as a salad. I could put some more croutons or some onions, gross, on my salad. Okay? Concrete is a mixture of rocks and sand and pebbles and the actual concrete substance itself. Rice pudding is a combination of obviously rice and milk and cinnamon and a whole bunch of different things all mixed together. But you can change all of those things. If you taste something, you're like, ooh, that's not sweet enough, you add a little bit more sugar. Or in rice pudding, oh, it doesn't have enough cinnamon in it, you add some more cinnamon. And see how with a mixture, they can vary from one sample to another. Okay, let's look at an example here. Okay, a pure substance is formed when you take hydrogen gas and some oxygen gas and you light a match, it will explode and you'll see it at a boom. Okay, and when that happens, yes, you see and you hear that explosion, but really what's happening is you're forming water. So the hydrogen and the oxygen atoms in the water are chemically bonded to each other. Okay, that again is a pure substance when they're chemically bonded to each other. A mixture is formed when, again, sugars dissolved in water. Although they are mixed together, the water disappears, which means you can't see it anymore. It does produce they are not chemically bonded to each other. You could boil the water and the sugar would be left behind. Okay? So within the pure substances, there's two things that we need to be aware of. They are elements and compounds. Any of the elements on the periodic tables, again, they don't vary from sample to sample. The element carbon is always carbon, and it's not anything else. You can't change it. Okay, so elements and compounds are pure substances. And then within the mixtures, there are what we call homogeneous mixtures and heterogeneous mixtures. Okay, now remember, they're still mixtures. It still means that things are mixed together, but they're not chemically combined. Okay, there's not a chemical bond in a mixture. Okay, a homogeneous mixture is one that is mixed and is uniform throughout, which means, and I always think of eating because I like to eat. So I like to think of if I'm drinking something or eating something that is a homogeneous mixture, it means the first bite, the middle bite, and the very last bite are all going to taste the same because it is mixed evenly or uniform throughout. Okay, and so salt water, Kool-Aid, even vinegar. Vinegar is water and something called acetic acid. That again, when you're using vinegar, well, am I taking it from the top of the bottle or the bottom of the bottle? It doesn't matter because it's a homogeneous mixture. Okay, whereas a heterogeneous mixture is not mixed completely and therefore isn't uniform throughout the mixture. Okay, I get a Blizzard from Dairy Queen and I take a bite. The next bite is not going to be the same because there might be a little bit more chocolate in that one. There might be a little bit more, I don't know, Reese's Pieces. Okay, think about when you eat a salad. A salad is a mixture, but it is definitely a heterogeneous mixture because every bite's a little bit different. You might get a little bit more salad dressing, you might get a little bit more of a crouton or a piece of cheese or something. Okay, so those are heterogeneous mixtures. So remember, mixture, not chemically combined together, just mixed. A homogeneous mixture means the whole thing's the same all the way through it. Heterogeneous means it is not uniform throughout. Okay, so here's kind of a flow chart here. Throughout it, you can see here's heterogeneous, here's homogeneous, there's homogeneous, I guess I should say. Here's pure substances, and then within the pure substances you have elements and you have compounds. Okay, so let's go through a couple of examples here. Identify the following as a pure substance or a mixture. So we don't care if it's elements or compounds, okay, or homogeneous or heterogeneous, just is it a pure substance or is it a mixture? Okay, helium gas. Helium gas is an element, so therefore it is a pure substance. It's an element. It's number 2 on the periodic table. Okay, sodium chloride is sodium and chlorine chemically bonded together, so therefore that is a compound, so therefore that is also a pure substance. Okay, a can of pop contains water and sugar and carbon dioxide, and it's all mixed together. And again, theoretically, it doesn't matter. It is a mixture of different things that are not chemically combined. So that is a mixture. A chocolate milkshake, again, has chocolate flavoring. It has ice cream. It has milk. Okay, and they are not chemically combined together. So that is a mixture. Air. What's air made up of? Air is made up of nitrogen gas, oxygen gas, carbon dioxide gas, water, etc. It's a mixture of a whole bunch of different gases that again are not chemically combined, so it is also a mixture. Okay, and the last one, concrete, we already talked about that. Concrete is rock and sand and the concrete mix itself, so that is also a mixture. Okay, example 3 says identify the following as an element, compound, homogeneous mixture, or heterogeneous mixture. So salt water. You've taken some salt, you've dissolved it in the water, you could boil the water off, okay? And again, that salt will mix itself evenly throughout the entire glass of water, so therefore that is a homogeneous mixture. Okay, carbon dioxide gas, carbon and oxygen are 2 different elements that are chemically combined together, so therefore that is a pure substance, that is a compound. Iron metal, iron is an element on the periodic table, so therefore it is a pure substance and therefore an element. Dirt is a mixture of a whole bunch of different particles from the earth, therefore it is a mixture. You could certainly separate dirt into smaller pieces. Sunlight. Ooh, trick question here. What is sunlight? Sunlight is not matter. So which of those is it? It's none of them because it is not matter. It is a form of energy. Okay? And then a fruit salad has lots of different things. Each bite's going to be different. It's all mixed together. So that is certainly a heterogeneous mixture. Okay, now along the same lines there, and then we'll finish with this. Along the same lines here is you talk about physical and chemical changes. And the reason I bring this up now is because it kind of helps us understand the idea of the pure substances versus the mixtures, okay? If you're going to separate a mixture, obviously you're going to take a bite of a salad, you're going to drink some of the drink, something like that, okay? But if you're going to try to break apart a compound, compounds are, again, elements that are held together in what's called a chemical bond, okay? So when that happens, you can have what's called a physical change or a chemical change. And in a physical change, something is changing its physical state, okay, or its appearance, but it's not changing its chemical composition. For example, water, H2O, when it's in the liquid form, and then it freezes. It's still H2O, but it's now in the solid form. See how on both sides it's still H2O? It was H2O liquid, now it's H2O solid. That absolutely is a physical change. Okay? Now, a chemical change is one where you start with one thing and then you end up with something different. Okay, the example that we have here is that hydrogen, so hydrogen gas, burns in oxygen. So it's going to react with O2 gas and it's going to make H2O. Okay, at the beginning it was hydrogen and oxygen and now it's H2O. Okay, and so notice that we've started with one thing and we're ending with something that's chemically different. That is a chemical change. Okay, and here's just a little bit more additional information about this. Okay, is a lot of times you're going to hear the term intermolecular versus intramolecular. Okay, and the difference between those two is intra means within. Okay, so within the molecule itself. Well, inter means between. So this is between one molecule and another, and this is within one molecule and within one molecule itself. Okay, when water boils or when water freezes or something like that, let's say water boils. When water boils, okay, the water molecules break apart from one another. Okay, and when that happens, water, when it's in the liquid form, is attracted to itself. So when you boil water, you have to break that attraction. So you're breaking the attraction, again, between one water molecule and another. Okay, you're breaking the intermolecular attractions between one water molecule and another. Okay, when you run electricity through water and it splits into hydrogen and oxygen, which is basically the opposite of this reaction right here, you are breaking the bonds within water. Okay, and so that's within the water molecule. You're breaking the intramolecular attractions within that molecule. Okay, so let's look at some examples here. How do we know if it's physical or chemical? Helium in a balloon leaks out over time. Was it helium before? Yep. Is it still helium now? Absolutely yes. That is a physical change. Eating a candy bar and it turns to fat. It was a candy bar and now it's fat. Okay, that's not the same thing. So you have something different. That is a chemical change. Iron is oxidized and it turns into rust. It was iron and now it's something very chemically different. It is rust or iron 3 oxide. That is a chemical change. Okay, table salt dissolves in water. Is it still table salt? You just can't see it anymore? Yes, it is. Okay, so therefore that is a physical change. And then plants use water and carbon dioxide to produce sugar. So it started as water and carbon dioxide, and now it's sugar. It also produces oxygen. Okay, that certainly is a chemical change. Okay, and that is it for that lesson.